What's up? I'm Jaco. Today we're covering data modeling and warehouses. This is the foundation of every data team. How you structure your data determines everything. Query speed, report accuracy, pipeline reliability. Practice every concept on dataforall.dev. Link below. Let's go. Here's what we'll cover. 8 topics. We start with what data modeling actually is, then the 3 types of models, ER diagrams and normalization, dimensional modeling for analytics, data warehouses, ETL versus ELT pipelines, schema architecture, and the modern tools everyone uses. Data modeling is the process of creating a visual blueprint for how data is structured. Think of it like an architect's floor plan. Before you build a house, you draw the plan. Before you build a database, you model the data. The definition is simple. It maps out structures, relationships, and constraints. The purpose is to bridge business needs with technical implementation. The outcome is a blueprint that guides everything from database design to application development. 3 levels of data models. Conceptual is the high-level business view. It defines the core entities and how they relate. No technical details. This is what you show stakeholders. Logical adds, attributes, data types, and keys. It's still technology agnostic. This bridges business and technical teams. Physical is implementation specific. Tables, columns, indexes, partitions. This is what your DBMS actually uses. The conceptual model is the big picture. Entities are your core business objects. Customer, order, product. No technical detail at this stage. Relationships define how entities connect. One to many, many to many. Business rules capture constraints from the domain. A customer can have multiple orders. And scope defines the boundaries of what the system will manage. ER diagrams are the foundation of data modeling. Entities represent real-world objects. They become tables in the database. Attributes are properties of entities. They become columns. Name, date, ID. Relationships connect entities with cardinality. One-to-one, one-to-many, many-to-many. And keys are the glue. Primary keys uniquely identify rows. Foreign keys link tables together. Normalization reduces redundancy and ensures data integrity. 4 levels. First, normal form eliminates repeating groups. Each column holds one value. Each row is unique. Second, normal form removes partial dependencies. Every non-key attribute depends on the full primary key. Third, normal form removes transitive dependencies. Non-key attributes depend only on the primary key, and Boyce code normal form is the strictest. Every determinant must be a candidate key. Sometimes you break the normalization rules on purpose. Why? Faster read queries because fewer joins. Better analytics performance, simpler reporting queries, pre-aggregated data for dashboards. But there are trade-offs. Data redundancy increases, storage costs go up, update logic gets complex, and you risk data inconsistency. The key is knowing when the speed benefit outweighs the redundancy cost. Dimensional modeling is optimized for analytics and business intelligence. Fact tables store the measurable data, revenue, quantity, cost. They sit at the center with foreign keys pointing out. Dimension tables provide context. Who, what, where, when. Customer, product, time, geography. Star schema puts the fact table in the center surrounded by denormalized dimensions. Simple and fast. Snowflake schema normalizes the dimensions. Saves storage but adds join complexity. Star schema versus Snowflake schema. Star is simple. One fact table, direct connections to dimensions. Fewer joins means faster queries. Snowflake normalizes the dimensions into subtables, uses less storage but queries get more complex. For most analytics use cases, star schema wins. Simplicity beats storage savings. A data warehouse is a centralized repository for integrated historical data from multiple sources, optimized for queries and analysis. 4 characteristics. Subject-oriented, organized around business subjects like sales or finance. Integrated. Data from multiple sources unified under one schema. Non-volatile. Once loaded, data doesn't change. And time variant. Historical snapshots let you analyze trends over time. The architecture flows from left to right. Data sources feed in, ERP, CRM, APIs, flat files, logs. Then ETL or ELT processes extract, transform, and load the data. The data warehouse is the central repository using Star or Snowflake schemas. And finally, BI and analytics tools produce dashboards, reports, and ad hoc queries. 2 approaches to moving data. ETL transforms data before loading it, runs in a staging area, best for structured, clean data. This is the traditional on-premise approach. ELT loads raw data first, then transforms inside the warehouse, leverages the warehouse compute power, best for cloud-native big data. This is the modern approach. Tools like dbt, Snowflake, and BigQuery make ELT the default choice today. 2 types of database systems. OLTP handles day-to-day transactions. Fast inserts, updates, deletes. Normalized for write performance. Your app's database. OLAP handles analytical queries. Complex aggregations across millions of rows. Denormalized for read performance. Your warehouse. They serve different purposes. Never try to use one for the other. Two related but different concepts. A data mart is a subset of a data warehouse, focused on a single department, sales, HR, marketing, faster to build and query. A data lake is a vast storage repository holding raw data in its native format, structured plus unstructured data, schema on read approach. It powers machine learning and advanced analytics. The cloud-native data stack. Snowflake separates storage and compute. Paper query. BigQuery is Google's serverless petabyte-scale warehouse. ML integrated. Redshift is AWS managed. Columnar storage. Databricks unifies the data lake and warehouse into a lakehouse. dbt is the transform tool for ELT, SQL-based, version-controlled, and Apache Spark handles massive scale, batch, and streaming. 6 best practices. 1. Start with business needs. Understand the questions before designing the schema. 2. Choose the right granularity. The lowest level of detail in fact tables determines what you can answer. 3. Use surrogate keys. Auto-generated integers decouple your warehouse from source system changes. 4. Implement slowly changing dimensions. Track history with type 1 or type 2. 5. Automate and monitor pipelines. Use orchestration tools like Airflow. 6. Document everything. Data dictionaries prevent tribal knowledge traps. And that's data modeling and warehouses, the foundation every data team needs. Head to dataforall.dev to practice. Every concept has hands-on exercises. Link in the description. Hit subscribe for more. Happy learning and peace.